Bismillahirrahmanirrahim. So we already have seen that the complex number, we usually use three forms to represent complex number: rectangular form, that is x plus jy, then polar z is equal to x plus jy, polar z is equal to r angle phi, and exponential, that is z is equal to r e j phi. So all these forms can be converted from one form to the other, right? And uh, actually, why do we use all these three forms for the complex numbers? So the answer is that some forms may be suitable for certain operations, and the other forms may be suitable for some certain other operations. For example, addition and subtraction are better done in rectangular form, right? And then multiplication, division, and taking the reciprocal and the square root, the suitable form is, for example, polar or exponential form. We usually will be using either the rectangular or the polar form. We will be seldom using exponential form, right? Because this is the implied form. Both are similar, so we will be using the polar form or rectangular form. So for example, if we have two complex numbers, z1 is equal to x plus x1 plus j y1, and z2 is equal to x2 plus j y2. And if we want to perform addition and subtraction and multiplication and division or certain other operations, so uh, for example, z1 plus z2 is equal to x1 plus x2 plus j y1 plus y2, right? And the subtraction z1 minus z2 is equal to x1 minus x2 plus j y1 minus y2, right? And for example, the multiplication z1 z2, so will be better using will be better off if we use the polar form. So for example, let's represent the polar form of this number, r1 angle phi 1, and for this number let's represent r2 angle phi 2. Remember that we can perform the multiplication using the rectangular forms also, right? But it will be convenient if we are using the uh, polar form, right? So in the polar form, the multiplication is given by r1, r2, and the angles will be added together, phi 1 plus phi 2, right? And similarly, the division z1 divided by z2 will be given by r1 divided by r2, right? And the angles will be subtracted, phi 1 minus phi 2, right? Similarly, if we want to take the reciprocal of, for example, z1, 1 over z1, right? So that will be equal to 1 over r1, right? And the angle, sign of the angle will be changed. If it's positive, it will be negative. If it's negative, it will be then become positive, right? And the square root operation, right? The square root, for example, of z1 is given by the square root of r1, and the angle will be phi divided by 2. So this is the square root operation. Another important operation is the conjugate complex of a complex number. Conjugate complex. So if we have, for example, z1, the conjugate complex is represented by z1 star here, and that will be x1 minus jy1. The sign will be reversed here. If it was x1 plus jy1, the conjugate complex will have x1 minus jy1. And if it was x1 minus jy1, then the conjugate complex will be x1 plus jy1 here, right? And In the polar form, uh, this will be simply r angle minus phi. Only the sign of the angle will be reversed here. Or in the form of exponential form, it will be re minus j phi if it was positive phi earlier, right? So this is the conjugate complex of complex number.